Hi guys. Okay, our lesson from today, I started out by talking about how up to this point when we've had data in a chart, okay, 10, okay, 0, 7, 9, let me just make up some data here. Okay, so here I'm starting off counting the y columns by 2's, but notice from 4 to 6 counts by 2's where the x's have been counting by 1's up to this point. So I'm going to have to actually make this a 19, and this counts up by 4. Okay. So we have some data, and up until this point, I could easily figure out what equation made this data. Okay, for that you need the rate of change and you need the y-intercept. And then you can write an mx plus b. So the easiest thing is usually the b because it's right across from 0. It's 7. Rate of change, again, as a couple different methods we talked about in class. When I see that the x side is counting by 1's, at least up to a certain point, and the y side is counting by 2's, I can do first differences. The first differences would be 2. I can always just pick 2 rows and do your change in x, your change in y, and then your change in y is on top, your change in x is on bottom. Okay, I just picked a random row, so my rate of change is 2. And I would just sub those values in. So 2x plus 7. And up until this point, that's been fine. But it's not real. And if you take your science labs that you'll take, this year, earth science, chemistry, physics, and you plot real data that you collect during your labs, you're going to find that those dots do not fall along a perfectly straight line. And so what we're going to be doing today, okay, so let's say I took data and plotted it, okay. The data that we just had would plot in a perfectly straight line. Okay, there might be gaps, but it would be perfectly straight. What I'm talking about is in real life, your data might be a little bit scattered, hence the name Scatterplot. Okay, and that's because you can't always control for everything that would impact your data. For example, if you were doing temperature readings in a room, unless you were in an extremely highly scientifically controlled room, something as simple as somebody being hot and opening a window can affect the temperatures that you're collecting in your sample, or the heater kicks on, or you didn't know it, but your Bunsen burner in chemistry kind of shifts a little bit. I can't imagine why that would happen. That would probably be pretty dangerous, but there's a lot of things that impact data collection. If you think about collecting data, if you were testing the efficacy of a drug on human trials, because people are unique and never everybody's different, it's really hard to say, you're never going to have a drug that impacts everybody the same way. I mean, there's gender differences, age differences, weight, race, genetics, and nutrition. There's so many different variables that you can't control when you're a scientist, okay? You can't make everybody genetically the same to do a drug trial. So when you have data like this, this data looks linear. It's in mostly an upward linear fashion. And in 8th grade, I would have you in 8th grade math getting out a ruler and kind of estimating you know, that would be too steep and that would be not steep enough. Kind of estimating a line that would go through those data points in generally the same direction. And we call that line a trend line. It's also called line of best fit. Okay. And your ultimate goal is, if the data were to continue in this same pattern, use the data to predict, use this trend line to predict what would happen in the future. Okay, now we only have so much space on a graph, so what we end up doing is finding the equation of this line. Okay, we end up finding the f of x equals mx plus b of that gray line, and we call that a regression equation. Okay, regression means to work backwards. Up until this point in class, I have given you the function for you to put into your y equals, and then you can go and look at the table that comes from that function. And what I'm going to show you how to do today is look at a set of data and figure out how to work backwards into a regression equation. How to find the rate of change, how to find the y-intercept. But when your data is not perfect and makes a scatter plot that's not a perfectly straight line, you can't just look and use our tricks. You cannot use the change in y over the change in x, and you may not have a data point at 0. So in your textbook, all right, this is page, I believe, 164. There's this data that I have not fact-checked to know if it's real, and I really don't want to get into whether we think global warming is real or not. Okay, but we have some temperature data. That's the average global temperature for each decade, starting at 1880 and going to 2009. Okay, now you notice this has three columns of data. All right, the decade number represents your x, and the average temperature, let me make that look better. That's what I get for writing with the mouse, is x, and your average temperature represents the y. And this middle column is years are numbers, yes, but if we were talking about months, we would have January, February, March, and those are words. So years we treat like words. We don't treat them like numbers. And there's really no way that 1880 to 1889 could be an input. Okay? So here's what we're going to do. You're going to go into your calculator, and I've pre-done some of this because it's time-consuming to do, and I don't want to, it takes too much time for the video. So I have some of it pre-done. Okay, so when you first turn it on, you got your normal blank screen. Alright, here's this button called Stat, and it's right next to your circle of arrows here. So you click Stat, and the default is to come up to the Edit menu. The only thing we're going to be using in the Edit menu is option 1, Edit. So you can either, it's already on that, so you can just hit Enter again. Now you can see what I have done. Yours will be empty, but what I have done is put all the numbers from 0 to 12 into the L1 column. L1 stands for List 1. Don't go further than that. You know who you are. Don't go further than that. Okay. Then, it's a little inside joke for a friend in 8th period. Okay. Arrow over to L2. I will say that you can, it sometimes doesn't like to arrow. There we go. Okay. Arrow over to L2 and enter in all this data. Yes, it's tedious to enter in all these numbers, especially when I tell you go slow, because if you do not go slow and you make a typo, you're going to get the wrong answer, okay? This is stuff I never had to do when I was your age because we didn't have these fancy calculators that could do this for us. However, the downside is, you know, if you make typos, you get the wrong answer. This is very easy, but you have to watch your typos. All right. So I'm going to assume you can pause this here if you want to, you know, get all this data entered in, and then we can move on. You can hit play again when you're ready. You've got all the data in. One thing I will say is be careful before you leave this screen. All right, I'm going to bring it up on here. Let me make it bigger. When you are in this screen on the calculator, the two rows at the bottom should be empty across from each other. If you have a value in L1 and you do not have a value to go with it in L2, your calculator will not do anything useful for you. It'll give you an invalid mismatch dimension error, okay, or something along those lines. And you would have to, if you see that error, mismatch, or invalid dimension, go back to your L1 and your L2 by hitting your stat edit and see if you have the same number of values in both sides. Okay? All right. Now, one thing that more comes into effect in tomorrow's lesson is viewing this data as a scatter plot. Okay? So the first thing you have to do, if you want to view it on the calculator as a scatter plot, is tell the calculator that you want it to do that. So the y equals is usually where we're entering stuff, but this time we want a stat plot. So see how it says stat plot above your y equals? Okay, probably not if you're looking at the screen, but if you look at your own calculator, it says stat plot above y equals. So we hit second stat plot. And if you are just turning yours on, all of them say off. All of them will say off. What you want to do is, we want stat plot 1. We want to hit enter so we get into the menu of things we can change on it. And it probably is off. Okay, so it's blinking off. Arrow over and make it blink on. And to be honest, don't fool around right now with anything else. Yes, you can make all kinds of different graphs, but we want a scatter plot specifically, so we want the first one. You're not going to change the list. What X list and Y list tells you is it's saying, hey, the values that I entered into L1, I want those to represent X. The values that I typed into L2, I want those to represent Y. We're never going to change that. Okay? You can also make your scatter plot boxes, plus signs, dots, smaller dots, nothing. You can change the color of them. Not really anything we need to fool around with, you know, during class time or whatever. Okay, then your data goes into the 50s. If you just hit graph, and I'm not going to because mine is set up already and I don't want to change it. If you just hit graph, you will not see your dots. So if you want changing the window, you kind of have to know what to change the window to. And your calculator will actually figure out what your calculator window should look like. So if you go to zoom, okay, hit zoom, and then option 9, zoom stat. Hit 9. Okay, and I gotta turn that off for a second. Like I said, I have all this programmed in already, and I don't want you to see that line yet. This is a plot of the actual data from the book. Now, these are temperatures, and we see like a dip, and then it's going up, and then a little dip, and then it's going up. But I think we can agree the overall trend is that the data is going up in a linear way. So in 8th grade math, I would be giving you a ruler, and you would be doing your best to figure out where a good spot to draw this line would be, okay? Because if the overall picture is that temperatures are going up over a long period of time, if you're a scientist, you want to know, when is the Earth going to be warm enough that all the polar ice caps melt? Or certain crops that grow in certain climates. For example, apples grow very well in New York. And what if our climate in New York changes so that it's warmer, and we need like a, certain crops need like a cold period they do stuff during the winter to like get ready for the next harvest or whatever. You would maybe start planting apples at a higher latitude where it's the right climate. So climates could shift. And so that line, the purpose of that line would be to help us see when that might happen, when that temperature change would reach that threshold. Okay? So for homework tonight, what I want you to do is enter in data on your homework questions. Okay? Enter in your data. And then you don't have to look at the scatter plots yet. We're going to look more at them tomorrow. Okay? We'll come back to this. What I want you to do on your homework is the next thing I'm going to show you on the calculator. Okay? You're going to find the equation of this line. Find the regression equation of that line. So I'll pull this up on the calculator. Okay. Now keep in mind, I left stat. I've gone other places. It does not go away. I could hit second, quit, and go do other work. And if I come back to stat and edit, all of my data is still in there. That data stays in there until you reset the memory or delete it out. Okay? If you delete it out, I will tell you you have to delete it one number at a time. If you go up to L2 and click the delete key, you will delete all the memory, but you'll also delete that column, and resetting the memory does not bring it back. You'd have to bring your calculator into me, and I'd have to go into the archive and bring it back. It's kind of a pain. I don't know how to tell you to do it. It's something that I just know how to do, but only when it's right in front of me. Hit your stat. We've edited. Edit is where we enter data. Calculate is where, after we enter data, Calculate can find out lots of different things for us. Okay, some of the items in this menu we will use, like later in the year we'll do 1 variable stats, 2 variable stats. Today we're doing linear regression, which is option 4. Now you'll see option 8 also says linear regression, but we want mx plus b. This says a instead of m. It's the same. We don't want the y-intercept first and then the slope or rate of change next. We don't want it in that order. ln regression, I think, is logarithms, natural logs. We don't want that either. We want option 4 only today. So pick option 4. Many calculators have this screen. If you have a different version of this calculator, it might skip this screen. It might show you something different. Basically, you go down to the word calculate if you get this screen. If you don't get this screen, oh, it just flashed there for a second. You probably get that other thing. Hit enter. Basically, hit enter until you get what you want, which is this screen right here. Okay, which I have in my flip chart. Okay. So in this screen, now I can take the information in it and I can write a linear regression equation. Yes, the numbers in here are long, obnoxious decimals. Miss Andrews, what do I round to? The directions don't say. But my recommendation is however many place values your data is how many place values you should round to. So our data in the chart went to 3 place values. So I'm going to round to 3 place values. Now before I just copy these numbers, remember I have to check proper rounding. What does 1 tell the 0 to do? Stay the same. What does 1 tell the 2 to do? Stay the same. So I would just take this value, 0.2, 110 and sub it in for the rate of change. The A is the rate of change. I would sub this value in for the B. So when I write my function, I can write it as f of x equals, you don't need the 0, 0.110, I mean the leading 0. We'll talk about the 0 in a second. X plus 56, I'm going to run out of room, 572. Let me make that a little smaller so we can see it better. Let's move it over. This is my linear regression equation. Okay, well, what can I do with that? You can go into your y equals, type it in, and now when you hit graph, it will draw it over top of your scatter plot. So as opposed to Math 8 students who have to do this with a ruler and kind of estimate where the line should be, you have an exact value, an exact line to match up with the data. And you'll get better predictions that way. Okay? So, as far as homework goes, this is what I want for homework. Obviously, do the vocabulary. However, the problem set says use your calculator to determine the linear regression equation, the correlation coefficient. Mrs. Andrews, we haven't talked about that. Yep, we'll talk about that tomorrow. Okay, that's this R thing down here. We'll talk about that tomorrow. And then the third thing is use the equation to make the prediction. Okay, all I want you to do tonight, is the linear regression equation. So if you're looking at the sample problem, it's this stuff, the rest of the stuff I didn't highlight, we will learn how to do that tomorrow. I'll teach you what a correlation coefficient or an R value is. I will teach you how to use your equation to find a value. Okay? Things to consider when you're working on the homework. So you're entering your data into L1 and L2. Okay? Then following all the steps. Now, you do not have to do the stat plot turned on. You don't have to look at the stat plot. All you have to do is get this data in, then stat, calc, option 4, linear regression, write the equation. Okay, so I showed you more stuff than you need specifically tonight. But in the scope of the whole homework assignment, I showed you things that you will still need. Okay, things to know. Years are in the form of numbers, but we do not write in, we do not type 2007 into our L1. We start at 0, 1, 2, 3, 4, 5. Okay, just like 2007, we treat more like a label, more like a word, as if like January, February, March, or Monday, Tuesday, Wednesday, those are words. We can't type those in. So it's more a label. And we start at 0. Okay, otherwise you're saying, all right, we are tracing every single experiment back in time to biblical times, year 0. No, we're not doing that. Okay, so 2007 is year 0 as far as the data collection is concerned. Okay, you'll get the wrong y-intercept if you don't do that. Weirdly, months do not work the same way. And I gotta tell you, I don't have a good reason for this. I contacted teachers at the high school, and Notre Dame I know teachers, and at Horseheads I know teachers, and I really could not get a solid answer out of anybody why this is true. But months are different. into your L1 for months. You're going to start with 1, 2, 3, 4, 5, 6. And the only thing I can think of is that it has to do with January is month 1 to keep the numbers consistent with how you would write them in number form for a date. That's all I can think of, guys. Alright, so when you're doing this, obviously in your L1, don't try to spell out the words January, February, March, April. Just put in numbers 1, 2, 3, 4, 5, 6. Okay? There will be another video for this lesson tomorrow where we talk about R value or correlation coefficient and how to make predictions. And otherwise, see you next time.